We got to do a Discord announcement. Nice. There we go. Okay, nice. We are live everywhere and we did announcements, so I remembered to do all the things. That's good. OCaml apply for creating new OCaml programs. Ooh, nice. That looks good. Like a pro. Yeah, like I stream. So let's go to Git and let's do Dune project or Dune init project goto ML. Dune init project goto.ml. Can I do this or no? OPAM update. I gotta try with the latest OPAM as well. I want to try with the latest OCaml because there's some new stuff in OCaml 5.2 that I wanted to test out with this. So, because I think OCaml. Oh wait, what? Use effect syntax for OCaml 5. Oh, is it OCaml 5.3 is the one that has OCaml 5.2 release? Because we'll test out which one has the effect. Data backend, dart sanitizer, experimental. Oh, so it must have been OCaml 5.3. So we need to test out OCaml 5.3, huh? OPAM switch list available. Do we have 5.3? Let's check. Let's check. Nice, we do. So we can try this one out. And I think it will work. OPAM switch create. We'll try this. We'll see what happens. What's effect? OCaml has these things called algebraic effects, which is another way of saying first class, native, delimited, continuations, which is basically a super fancy way of saying resumable exceptions that are part of the language. So we're gonna see if we can use them to do some funny stuff with making like a go-to like thing. Sozen had a really cool video about this a while ago, so I figured, and he says if you can think of a cooler way to do it, then you should give it a go. So we're gonna see if we can give it a go, basically. Because I wanted to check OCaml multi-core effect examples. So this is a OCaml 5.3 add effect syntax. So this must not be released yet. Yeah. So that's consists 5.3 trunk. Nice. Very cool. So we should be able to try this out in a sec, which should be a little bit fun as well. Does that answer your question, Mig, or do you have are you wondering more about that? Oh, what up, Real? Oh, I forgot to add commands edit today. Inspired by @Sozen's video about implementing goto and OCaml. We're gonna try and do the same thing, but with algebraic effects and OCaml 5 features. Pog champ. What up, Ed? Okay, so we need to also do OPAM install -y Merlin. OCaml. We'll see if any of these still work. We'll see what happens. But Mr. Director said goto considered harmful. Oh, it's going to be harmful, yes. Both to our sanity and everything else. No agreement on version of OCaml. Okay, so I don't think we can do... I think we're going to have to do this without... Oh, well, no. Let's do this. We do this without core, maybe. We'll see if any of these works. You hit a Mohit, good to see you. OPAM pin add dev. I wonder if this will have this or not. We'll have to see, I guess. Packaging conflict, missing dependency, LSP. OPAM pin add LSP dev. We'll see. The video, by the way. Oh yeah, we should probably link. I can link it in the. Yeah, we'll link it. Thanks. That's a good call. Commands edit today. We'll do this. We should put this as well, just while I'm thinking of it. Original video. There we go. Ooh, nice. Are we actually still going to get OCaml LSP built on this? I didn't think we were going to get OCaml LSP built here. I thought it would be a lot, but it's insane for how much information there is. Well, it turns out types are kind of big too, you know? Okay, nice. Okay, nice. Wow, so we might actually be able to still have OCaml LSP. I thought for sure we were not going to be able to have OCaml LSP. Dune run test W. Okay, nice. Dune exec bin main W main git ignore. We should really have a git ignore for this. Git init, and then let's do malua.git ignore. There we go. Okay, nice. What did the message just say? Language server OCaml LSP failed. OCaml was just not installed. OCaml LSP. OPAM install devs only. I thought we got LSP to install. Maybe it only installed the first one. We'll have to see. OPAM install OCaml LSP server. Dude, oh, I know, it's so real. Okay, interesting. So we can't get OCaml LSP to work. That's fine. I wasn't really thinking we'd be able to be honest, because it seemed kind of insane to be able to get that to work. Let's try and do install Fumt. Let's see if that works. What I'm doing? $5 a month. All right, gotta add that to my libraries. Or main MLI. Oh, right. I gotta say. Wait, did that not work? Why did that not work? IO I don't even know what that means for this case. Fumt. Interesting. Okay, interesting. Okay. Take my money. I will, Russ. Thank you. All right, so what we're going to try and do is we're going to try and kind of copy some ideas from Sozin's video here, which eventually gets down to here with this sort of go-to block. But I think we could... How did you do this terminal like this? I have a mapping for this, which just says Control W5 and then the left one there. So that's meta. That's like Alt and comma, because that's where less than is, and Alt and dot goes the other way. So I don't think we're going to be able to get, I don't think we're going to get any completion, right? Yeah, okay, that's fine. So let's try and look here, because we're not going to get these to work because we are, like I said, in OCaml 5.3, which is not released. So that's not a real So we need to do something here. Oh my goodness, this is so much better. Dylan, have you seen this? I don't know if you're still here, Dylan. Have you seen how much better this looks with matching on effect versus this ORETC exception? It's like, oh, people might actually use this in their language now. Okay. It's like, oh, that looks good. All right, so let's do open effect and open effect deep. Okay, that's fine. And let's try and do something like this. Let's just make a simple one here. Type f plus equals, and let's make our own thing, which is just example string, something like this, right? Does it have to return? Does it have to do this? Can I do of string? I can just do this, right? Yeah, okay, nice. So now we can try and do something like, we need to do perform, right? I haven't done this in a little bit. I need to use perform somewhere, right? Ah, right, yep. So let's do let send example or something like this of s is perform. Okay. And then we also need to match against it at some point by doing run. Who is running? Who is doing the run? Grad 2, grad 1. Maybe we should pick a simpler example. Why don't we just pick a simpler example? Sure, a loop would probably be most of the way that we want to go. Oh, nice. That's cool. What up, Oscar? Okay, so then we can try and do something like... So this could send this. Match F this. Okay, let's match send example hi with, and then I can do effect example, what do I say here? S K, I think. And then when it's nothing else, then we're done, I guess. All right, because I can say something like this. I could say like sending resumed. I think like this, something along these lines, right? And then this would be like anything else, and we'll say done. And use variable k. That's not how we do it. Oh, right, I have to actually call continue on this. Doo-doo-doo. Function with nothing. What do we do with continue? That's the part that I don't remember. Because what are we going to do with this again? Continue. Continue KR. I don't need to send any more effects. I'm just sort of like all done. So what do I do when I'm sort of like done? I am add find max. Because I'm not sure OCaml effect deep. Ah! Sorry, that was brighter than I thought it was going to be, chat. Continue. Continue K extra zooms the continuation by passing X to K. There should not be a function. The type is effect. Okay, nice. So we got here. Now we want to resume doing this. I'm not sure what I'm supposed to yield, perform yield, spawn, perform yield, send, yield, receive, perform this, sum this, nothing. Do you want to try my game? It's in the web. No, I'm all right. Thanks though. Continue K with a message. Expected type effect. So we need to send some effect back. Has type A of expected type. I don't know what this means. How to create a demo processing shell for uni? Anything goofy you want to add in there? Oh, have to create a daemon process spawning shell for uni. Was it a jump scare? What is type? Nice. UK PID. What does in Q do? I don't know what this type is. I don't have any way to go to the definition of this thing either. OPAM, lib, effect. I don't even know where this would even be. Effect, standard lib, I guess. Okay, nice. Continue. Val AB takes some continuation. Okay, that's the K. Continue. And then A, and then it returns B. Rick is going to call this... It's going to call it back on itself. Oops. Okay. AB continuation. Continue resumes the continuation K by passing X to K. Already resumed, continuation already been resumed. Discontinue. We can also discontinue, which is kind of fun as well. If we go discontinue K, failure, oh no's, we'll get this. That makes sense. Okay. I'm remembering this now. But how do I make it so that instead of doing that, we do this? That's a good question. What am I supposed to pass here? I'm just supposed to pass A, which should be... done? That doesn't make sense. That's the part that I'm not sure. Almost a year. True. You'll finally get the upgrade. The really nice upgrade. So where do we have continue? So why can they pass this here? Message. Stop candidate of like where is continue gets to pass K and nothing. I didn't really get this part. Why can they do that? Type unit, but expression type effect. Garland, hey, thanks for the Twitch Prime. Appreciate it. Let's continue with backtrace. What's up, Pac? Perform this. So we're getting to here. I want to then send myself back to this. Oh yeah, no problem. And then get resumed, because that's what we are not getting right now. We are not getting resumed. We'll get the got right here. Hi, that's good. But then we never resume this K. So I thought we'd do something like this. So I must be missing something. I must be missing something. Maybe we need to pick a simpler one again. Let's pick effect syntax. Fringe, generator, pipes, promises, ref. Sure, we'll try a few of these and see if any of them make more sense. Or do I need these to be something like this, where we say that this... Oh, maybe my effect needs to be something like this. Example, string unit. Okay, we'll do this. And then I say this. Oh, okay. Okay, I'm with you now. If I said bool here. Oh my goodness. I didn't know you could do that. That's so cool. Peri sauce? I don't know what that is. Okay, well, that's really cool. I didn't know that you could say that this thing has to send this effect back. That's very cool. This is OCaml. It's a pepper. Oh, interesting. Is it spicy or what? This should error now, right? Yeah. It's with a bit of sweetness. Oh, nice. I like peppers with a little bit of sweet and spicy. Heard good things about it. It's a very fun language. Very fun. Okay, you should try Sugar Rush Peach Peppers. Sugar Rush Peach Peppers. Can you fix these bugs with quick command sudo rm rf root? Sure. Sudo rm-rf root. Didn't seem like it did anything. But maybe next time it'll work. I don't know. What color scheme is that? It's my own. It's called Groove Buddy. Yeah, maybe next time, Dr. Cartoose. Alright, so... Okay, so this is pretty cool. So now I'm wondering... So let's say we make something like this. We make some I love horror games. Oh, hey, effects. Yes, but we're not doing what you should do with them. So you may want to turn the screen off. This is going to be not very well typed. It will be somewhat witchcraft maybe, but not very well typed. I don't have a go-to. It did come from Monad. Oh, nice. I was thinking about could we do come from with algebraic effects. So that's great, actually. I don't know if you've seen this video. This is a pretty fun video. Where Sozin implements goto. Like sort of, you know what I mean? Like it's sort of go to, right? Because but it's like this, and then you go to some loop here, like this kind of idea. So I think we can do this. I'm sure you actually place and you can't do that. Oh, interesting. Oh, okay. It does say that you'll raise an exception if you try and continue something that's already been continued. But we're going to try and do something like this, but with effects. I mean, it's going to basically be the same. The other sort of funny thing is like, we're just going to discard this, which is maybe not a good idea, but I don't even care. Because I'm not going to use this in production. but that's okay. Because I was thinking you could basically do something like this, labels, and you could have something like, in this case, loop and out. And then you would have something like goto, and it would be some labels to labels. But this should probably be label to label. We don't need to call these labels. And so this would be like goto, and then you could have some label like out, right? And then here would be like label out, or out, like this. Goto out, right? Yeah, so then you could say got s. There's no s. Yep. Whoops. And then this should just do some other label. What would we do here? We actually aren't going to do continue. This is like where we would write our thing, right? So this is like effect go to loop. And we would say like this or something like this, right? We could go here. You could have a particular piece of data of int if x greater than 10, then yeah, can we do this? Continue loop x plus 1. No, if it's greater than 10, I want to do loop. I want to do go to out. Does this work? I don't want to continue this. I think I want to perform it, right? I want to say like go to perform go to out, something like this. This probably won't work, will it? Type label, but okay, so it should be that each of these returns units. Looping and a digit here and x. And so then what are we gonna do? We're going to, we just start with go to loop 1, something like this, right? And then we don't need these anymore. What do you make? What do I make? Code, usually. Effect unhandled. Okay. Oh, right, because this needs to like, right, because now we're here and we're not handling this. Oh, right. So I need to like recursively call myself here. Can we do this easily? Because, so I guess that's what, he has like go to block and then he has go to impl and we're here and then we go back and we call ourself. Okay, right. Because this won't make any sense because we're not going to handle the effect. Go to our agency plus so you can use it. I'll consider that. I'll consider that. Yes. OCaml by camel. Okay, so that makes sense. That makes sense because we're gonna we need to say how we're gonna match this, right? How can I do this easily? Oh, I guess the trick here is that each of these are functions, right? So we need to do something like let right. Yes, because we want to basically like do this later. We're gonna handle effect here. We're gonna get a go to, and then we need to go back and call these again. Keep going. Okay. I actually don't know how we would do that with like a match. Because the thing that we want to do is be able to write this perform, and then we just immediately go back to our effect and we're going to discard it. So it is kind of goofy because it's sort of like, for exceptions, that's actually what you want, is to just discard it and not do the rest. And effects are made so that you can continue it, which makes sense. That's kind of the point. Because almost like you want to do like let's say like loop, right? N, I don't know. And then we're going to do perform loop go to loop n+1, something like this, right? This kind of idea with loop. So then what are we going to do here? It needs to call itself again and call these handlers again. So it's like and let and handle match yeah, so now we're gonna kind of do this idea here. Effect go to loop k. Something like this. This won't really work because it's not gonna make any sense. So let's also let's go let what do we want to even call this? This perform go to loop x, let send out, perform out, something like this. Okay. And then this, let's comment just all of this code down here. Rec loop here, hello world. We're not even calling anything though. Oh, right. There we go. Okay. Handle. And this is just like this, right? Handle. Right, so this is like do loop. And do out. So let this is handle fun send loop 1. Oh, no way. Oh, that actually worked. That actually worked, chat. Look at this, right? So we actually got the looping to go. Now the question would be, can we write this in like a much easier way? Right? Can we write this in a way that we don't have to write so much goofiness here? There's no way. Lazy OCaml. I don't know that this would work. I've never actually used lazy, but I'm wondering if we can avoid. I guess it probably doesn't really matter that we're doing these closures. Oh, we could just do handle. Instead of doing this, we'll say here and f and args, and we'll say args here, and then we can go here and we can just go like this and like this, and then this should just be send loop 1, right? Handle do out type unit, but expression type int to unit. Right. Oh, I guess they could just each pass a label, right? That could work. And these both just take this, and this takes... Oh, but that's kind of annoying too, because like you could pass the wrong thing here. Haskell smugness was at top levels. Oh, I believe it. I believe it. Okay, so this makes sense because we needed to be able to say that this argument could be either thing. Can I put this at the end to sort of say like we're at the end? Yeah. That's too good. Okay. So this is like the same thing as did we actually just make the same thing? This is loop and out, right? So this is kind of like loop and out. We didn't have to pass a ref here. We can, I guess like we could hypothetically, but like we can actually put the data inside of the labels, which is kind of fun. And these always return, they return a unit, right? So then when they're done, it's like we're finished, right? So we're just going to be done. It's like we got to the end of our section. Does it work if you give explicitly polymorphic type? Oh, that's a good question. We can try that. A to B, right? A, B, F, and A. Oh, then don't I need to say equals fun F A like this or something? I always forget how this actually works. This type of unit, but is less general than this. Do I need to? Then do I need to also do F A to B? Oh, right. I got to do the like, I got to do this like type A, right? Type A. A. B. And we go here and we go here like this. And then we go A to A. And this returns B. Something like this, right? And then this should be... Oh, they always should return a unit. So I can say this, though. Unit and unit. And here we can go here. And then this can be units. And then this can be unit. Right? Ignored this. Application is missing partial. If true equals false. OCaml looks so arcane. Well, to be fair, we're trying to implement goto in a language that doesn't have goto. Usually, you're going to use weird features in weird ways to make that happen. Oh, this needs to be send loop and 1. Oh, let's go. I would like to write parsers in C, don't you? Oh, man. Okay, nice. So we actually can. Nice. I didn't think that this was going to work. But it does. I guess because we do have like a real top level type. We know all of these ahead of time, so it's okay. I guess these don't have to be recursive either, right? Right? Or no? Handle. Oh, this needs to still be recursive, but that's fine. The other ones do not. What's your keyboard? Right there. I heard OCaml debugger can move backwards. Goto won't break this. Well, it's not really goto, and I would never use this in real life, chat. But this does let us just do gotos, which is pretty funny. And if you wanted to have shared state, it would also not be very hard, because you would just do something like this, like let in. What are those things on top left are interesting? What? Oh, this is, well, I'm using Pop! OS with awesome WM. These are my workspaces. Where did I do? Oh, right. So then we can say this handle send loop 1. Okay. So if we wanted to have some shared state, like we were writing this normally, right? You could have like let shared is ref 0 in this, and we could say like shared plus n. Sure. Right, if you were trying to do this in like a weird go-to style where you had some shared state here, right? Nice. Did you read bunch of documents? Wait, for what? I do read a lot though. What if we were mutable refs, go-tos? Now we're doing proper OCaml. Exactly. Called Exapunks. Interesting. Cool. Cool animated music. Nice. Okay, so now I think we have basically the same thing here that that Sozin has, except ours comes with a little bit more fun because we can pass data to the labels, right? So we can pass data to the labels, which is fun. We can oh, we didn't even do this. We can do out and loop. So send loop. So let's just say loop 1. And then we can say out. We could all, I wonder if, can we also do this? Loop. Oh, I need to go like, right, like this. Because then we could just say go to out. I don't think that that gives me any benefits. Out. And then we can say loop n plus 1. Which is funny because like you're calling loop. This is so funny, dude, because like you're just calling loop, but this function is just called do loop. We don't even know. That's pretty funny. That part's pretty funny. Now, can we make it in some way so that you have... You could declare these in a way that looks a little bit more like... Because like right now, they're kind of far apart. I kind of want to make it so that you can write something... Like I do like this. How he had something like, you know, loop and then some function here like this. I like this. Continuations are actually a really cool concept that are used in compilers, and all you need to have them as first class functions. Yeah, I know CPS. OCaml with for loops. I feel like object oriented. OCaml is next in the menu. Maybe we could do this with objects as well. That would be pretty funny as well. Right, because we're basically just going to discard our continuations. We don't care. OCaml. I was also wondering if maybe we could make something where we have like we could make like a module that has the go-tos. So like say we had something like this module type you know, go to sig end, right? And it would have some type effect here. Actually uses OOP side of OCaml. I've used it. It's useful for row polymorphism, guys, of course. And visitor pattern is also a nice reason to use it. But it's really not that, it's not used that often. Oh, we can say like type label, okay, right? And then we need something to, because these are all labels, right? These are all like a label. So then we have what we really have here is a label effect goto label. Oh, that only probably works because okay, so I have to think about this. UI requires inheritance. I mean, it doesn't require inheritance. That is one method of doing UI. Okay. I got to think about this. I got to think, because then what would we do? We would do module, like, make goto or something like this, which takes, we're going to call it G goto. And, right, and we'll have some like type effect plus equals goto, G label the unit, right? That part makes sense. And then we'll have something like this probably. Okay, so that still compiles. So then I don't know if I can think of a generic way to say what you would want to do here. You could probably get away with macro generator label here with unique generations. I'm not sure. Yeah, it kind of feels cheating if we start like using macros, because like obviously you can make goto if you just rearrange the code. You know, that seems kind of like cheating. I'm trying, so this part works fine and it's actually pretty cool, I think. Oh, if we go, are you talking about PPX? Okay, so let's say we do this, right? Do I like these better like this or like this? I don't know. Maybe we do this. Loop. Okay, so that still works. That part's fine. So then I'm thinking, okay. This could take loop X, right? And we go to do loop here. And then this would just be label X or N like this. I don't know if that even works. Maybe I need to do that crazy constraint thing again. I haven't really figured that out super well, because this is like, oh my goodness, because now we have the expression type unit f, but expression type label of int as label. Oh no, this needs to be here, I think. The second variable type does not allow tags. Loop. Let's just try this. Let's just make sure we're doing this right. Loop X. Oh my goodness. That's because I said label instead of loop. I'm dumb. Loop N. Okay, hodl with me. Hodl with me here. I don't know if it buys us anything. The only thing I was thinking was because then you can write basically like... No, you would have to still like PPX this basically. Because I guess what you could say is you could say effect. And then you could say go to. Like label. Handle F label. But we don't know how to get F. This is type G label, extra type A. Oh, right. Yeah, because we have to pull these out. I don't think that's going to work. That's one thing I'm afraid of most in OCaml. I don't, there's not that much to be afraid of for PPX, I don't think. I've written some PPX stuff. I thought it was, like if you're using PPX deriving and some other stuff. I mean, obviously, like, it's not easy, right? But it's not so crazy either. Okay, so what if we do something like this then? And we say, let's see if we can write this. Let's see if we can write this separately. So can I do something like this then? Can I go... no, I can't do a pattern matching now in this case. I can't hold the data inside of here if I want to do it, right? Because now we don't have... I can do... No, I don't think I have the capability to do anything like fancier, like make some sort of go-to handler or any of this other stuff, right? This part works good though. I mean, this part is still funny because it's still like, we're going to just say out, and then this part never happens. First time chatter here. Which OS are you using? I use Pop OS with Awesome WM. So I don't know that we're going to get a much bigger win than this. I got an interview request where I had to implement a PPX, but I couldn't, so I'm afraid of it. You had an interview question about a PPX? You were interviewing someone with OCaml? That's pretty dope. I guess then we can do we need to have something like val handle, and we need to say label units. You're attempting to create goto.js or just create closures with labels, add to a package, put an MTM to the bliss of the JS ecosystem. Exactly. Maybe we won't even need this, right? We'll have something like let handle I don't know, let's just write something like this for a sec, right? Where you would go F and A for right now. So we'll say match F, A with assert false, and then we'd have effect, go to label, G handle label. So this would work. Oh, we need to pass ourself to this. Rec handle. We can say sort of like this is like chunk or something like this. And we go down to handle here and let's say chunk. And then we can say that this is some, I don't know, we'll say I don't know what would I call this? Oh, the handle. It's going to come back and call F and A again. We'll just say this right now. Just some other type. Potato? Hey, thanks for the sub. But Shubham, we need more info than this. Where were you asked to make a PPX in an interview? That's awesome. It was great that you didn't pass functional interview the messing you ever had after some time. No. They're fun. They're very fun. So then this would be some label. here, we're going to chunk this handle and the label. And so what we need to do here is we still need to use this handle. Because what did we do down here, right? We said, okay, handle, and then we're going to pass back our function and an argument. Okay, so maybe we still write this. Oh boy. Can I even, there's a company called routine.co. They're an OCaml shop. Oh, nice. Yeah. I saw them. But I think they're just in France, right? Or something. I don't know. They're somewhere in Europe. Seemed like a cool shop. Yeah, in France. Okay, so this is actually going to be some type here, which is like handler or something like this. And we don't know what a type handler is here. Type handler is a unit, right? Oh, so we can't do this. I think we can do this though, right? Oh, we never got, wait, did we not get to the end somehow? Do out. Was it running? Oh no, that's just because we had dash W. Okay, nice. Force it! Living in So's shadow. No, we're trying to do exactly what he asked us to do in the video, which was if you have a different idea, try it. So that's what we're gonna try and do. Okay, so if we do this, this still works somehow, which is surprising. Okay, so let's try and make one. Let's try and do module simple. Goto. So type label is yeah, let's do the same thing we did before. Loop of int and out. Okay. And we don't have a function chunk, right? So let chunk f is here, right? So then what are we gonna do? F and some label. Okay, so then we can do complete is make goto simple. Okay, and then can we try and do let's complete handle. What are we gonna do? We're gonna say F and A. Oh, we need something like val start, which will just be something like no, that's what has to happen here, right? Let start is oh, it needs some initial value. If anyone can join now and think to themselves, why you do all this stuff to get simple for loops? This looks so ridiculous funny. Oh, well, we have for loops. This isn't for loops. This is for gotos. For loops are just like a while loop is a really simple application of a goto. This part isn't as elegant though, because we're gonna say handle this label, but oh man. So how did we do this before? We basically said, let's think about this. Basically like match F V, something like this with effect here, go to out like this, right? So what are we gonna do? Chunk needs to take a handle as well. So then we would say like handle. This is where we need to get our loop function. This is where we get our loop function, right? Because that's what we were doing before. That's this like do loop part here. And there's not really a great way to write this anywhere newer. I want to see all fails, so my faith in you remain intact. We got the simple version of this working already. So we can go like let loop x, and then we can go to this do loop here. We'll yoink all of this here. Let do out. And we'll get rid of shared for right now. Oh, we'll do let shared ref 0. Okay, we'll do this. Because then this is like handle, loop, and x. And then this is like handle, out, nothing. Chunk, handle, F and V. So we do F and V here, boom, boop. We match these, and then we do handle, and then we keep calling handle. Yeah. Where is this? Line 35? Oh, right. Yeah. Make go to G. Oh, G chunk. Okay, we need to put this down here, like this. Has type loop 1. Oh, right. So it needs to have a start. Is LSP confused? LSP is dead because we're on 5.3, D'Artagnan. So it doesn't work at all right now because this version isn't released yet. Because I wanted to try it with this syntax here. Wait, effects? Wait. Nice. So we just don't have the LSP installed at all, basically. Chunk, handle, label. Chunk should take a handler and a unit. Right. So chunk should be handle, F and V. Well, that doesn't make sense. Oh, yeah, it does make sense, actually. Need a drop? Hey, thanks, Animated Music. Appreciate it. No worries. What's up, Danielle? Are we doing OCaml 5 effects handler magic? Yes, we are. We're trying to see if we can make very goofy looking go-tos. Living in the future, we are. We're living on trunk right now. We installed OCaml 5.3 trunk to get this, to test it out. So the simple version works, which is like we have this like do loop and do out here. Maybe this instead should be called, let's yoink all of these and let's put these down here. Um, 38. Oh, right. So this would be like go to out. I don't really know how you would write this easily. Let out is perform go to out like this. Oh, this is just out. Oh, nice. Oh, this doesn't have the, it doesn't make it into an effect yet. Oh, that's interesting. Oh, that might not work either. All you need is LSD. Wouldn't know. Oh, that makes this a little bit more complicated too, right? Because we're going to say we need like a goto. That's actually kind of cool if we can do this though. (41) loop go to n. Yep. (49) effect go to loop handle. Right, so we need something that lets us perform an effect. Really welcome to response edit. Dan Yale. Dan Yale. There we go. Nice. Okay. I think I was like, I don't remember what it was every time. So this isn't right either because we need to also pass a... This also has something like label. Label to unit. It does nothing. So then we need to handle something that just goes let go to label perform go to label, and we pass that here. What did I say chunk should do? It should have a handler. Yeah, and then it should have a go to. In pattern type app, there's no constructor go to within here. There's no constructor go to within type app. What? G chunk handler label to unit. So this should take the same label and it should return unit, right? Go to loop X. Oh, right. We can't even do this. Oh. Oh, okay. Chunk. This should pass like go to these as well. Okay, so now I'm thinking this. Oh, no way. So the only time we're going to call this is if we have something from our label. So these. Oh, it's going to think that this is going to think that this goes forever. Okay, well, I don't know yet, so we'll have to think. We'll think. We're thinking, chat. We're thinking. Because this needs to pass F, and it also needs to pass go to, and then it needs to pass V. So then we have F, and we have like go to, and then V here, right? Here, we're not going to get this effect. We're going to instead get F is going to be this function. We're going to handle this function by calling... Oh, but we don't have this effect yet. That's kind of the annoying part. Maybe I can't make like something that does this. I was really hoping to make a functor that would sort of like make this look much more magical than it is by being able to say like a label, right? Oh, this also needs to take a go to, but it's just nothing. It's not going to use it at all. Because then I was kind of thinking, okay, can we make this? Oh, we could call continue. Oh my goodness, could we call continue on this or something somehow? Wait a second. Because then I was thinking, what if this, instead of returning match F, goto and v. Okay, because now I'm thinking, chat, instead of calling, oh no, oh my goodness, my brain. Basically, I want to see if it's possible that we can match only on the results here, and we can sort of say, okay, which function and arguments do we want to return? Maybe so instead it's like let handler, and we get some label here, and then so we say, okay, let's match label with, and we say loop x, and we're gonna say this. And then we say out is out, but we're not going to do it like that. We're going to go something like this and this, right? Or we can say something like, oh, we want to do this function, nothing to this, right? And we can say here, and then we'll say function, nothing to this. So now both of these return. Oh, right. They both have to return a goto. Ooh, chat, we're getting closer now. We're getting closer now. Because now this is like, okay, so you would just write this here, right? So you're saying, okay, this is what I want to do when I get loop. This is what I want to do when I get out. Let's change chunk. Instead of that, we're going to say let, or val is going to be, we're just going to call it handler, right? Handler, and it's going to take a label, and it's going to return some function that has a some function that takes a gotoer. OCaml, I don't know yet. Scary and exciting at the same time. Yeah. So this will be like this takes some function that's going to return a unit. And this is also going to return a unit like this. And then let's comment out chunk. Because then what we're going to do here is we're going to say, oops. No, let's go like this. We'll go here and let's go let handler is g handler label in handle f. Something like this. So then we're going to call ourself back again. This isn't going to work right. This isn't going to work quite right yet because handler is not the right type yet. This is label, some function here, handle here, effect, goto. Okay, so this part we just delete. We just delete this part. Okay, and so now we're getting closer. Now we're getting closer. Oh, right. This should be label. Oh, that compiled? Okay, that makes sense. This wasn't right. This is G label unit, but an expression type unit to unit. Oh, right, because we need to pass our gotoer to this, right? F, some function that takes nothing. This is a function that takes a label. Oh, probably I need to drop this one here. So that a handler should take what? A handler takes a label. Oh, no. And what does it return? Yeah, it returns this. Something that takes a label to a unit, Oh, maybe to a unit. Oh, now we're getting close, chat. Oh, I see. I'm going to need to read into all this effect stuff. It's very cool. It's very, very cool. Oh, I see. This one could be either of these. Oh, that's tricky. This feels wrong. Oh, it's very wrong. Standard format. Oh my goodness, 6 months in advance. Thank you. Appreciate that. Really appreciate the long-term subs, chat. Very helpful. Okay, so the problem is here, this goto, we're saying right here, okay, well, it could just only be out. Right, so we don't know that this one is unit. So we could say label unit like this, I think. Val, includer, handler. Oh, do I have too many units here? Well, this is where the LSP would be helpful because I could tell how far I am. Oh, I think this might need to be here like this. No? We should just look. Okay, so we have a label. That's argument 1. Handler, we get past a label. So what do we return? We return a function that takes a goto thing and returns a unit. Takes this as the gotoer, right? Type gotoer. Let's say gotoer. I don't know what you would call this. A unit to unit, right? So then this should probably just be label gotoer, right? Isn't that what I want? At the expression with function this. Handle handler. Konnichiwa, welcome. And goto will make OCaml more powerful. Indeed. I use Awesome WM as the window manager, Creton, on Papa West. Oh, the Elixir. He sounds a little shy, PHPP. Can you confirm? So this goto takes a label and returns a unit, right? It takes a label, returns a unit. And this whole thing returns a unit. Wait, maybe I'm just doing this wrong. Oh my goodness. Okay, let me think about this. No, that seems right, because the handler should return this function, right? Let's get rid of this handler because I'm confused by that. Oh, it also needs to return a unit here for sure. Yep, expression was type label goto or unit, but expression was typing another unit? That doesn't make sense. Unless they're saying like this. Oh, actually this should. No, because let's call this get handler. Handler, okay. Say get handler. And let's go down to here and say get handler. And this should return a label gotoer, right? So then this, when we call handle again, handler, get handler label. Expression, oh my goodness. I don't know. What am I forgetting here? Maybe is there an easier way to get this to print out what it thinks the type is? Okay, so this expression has G label gotoer, which equals G label unit to unit, right? So it's a function. Takes this expression was typed this. Unit is like the empty thing. So like this is a unit. So it's like nothing kind of in a sense. Fun, go to here. Oh, we need to do this. Oh, no way it compiled. Oh, nice. Because now we're saying the only thing it takes is a loop here. Okay. Okay, chat. Now, is this really that crazy? I'm not even sure if it's that crazy or not. Because you can write this. But okay, so let's just try here, right? So we can say... one sec, chat. Okay, we're good. So let's go... complete handle F. One sec. Oh my goodness, dude. Kids are so funny. Okay. Did you forget this? Complete handle loop. So this doesn't work because we're going to say complete. We don't have a loop yet. So what do we want to actually do? We want to say fun, go to loop 1. Expression type simple label. Is that not? So why wouldn't that work? Complete handle. Oh, we should expose label. Whoops. Complete. Dot this. Can I do this? Was expecting type loop of int was expression simple dot label. Huh, okay. It's kind of weird. Okay, then we should have new L is L. Let's make something like go to should be val new. I don't know if that works. I don't know. Does that even work? Oh, I can't use new. Make, right? I think. Why does it not work? Why do you not work? I don't know how to do this. Is the functor? Nice meta. Well, I don't know how I can get... Oh, we could make the type available outside of this. So we could go... let's find all the places we said make, and let's just get rid of that. So we just have to be able to see this somewhere, right? So we can just go here. Go to loop 1. Expression has type loop of int. Expression was type simple label. I must be doing something wrong here. Go to label should be this. I don't think I can do this, right? What up, Morano? Good to see you. Huh. That's really weird. I didn't think that that was going to be the case. Okay, nice. That works this time. Maybe because I didn't say that it has to be this thing. Okay, so let's try and go down to here and comment these out for a sec. And no way, that works. That's pretty good. So in this case, all you need to do is you say... We could also say that it needs to have some start state or something like this. I don't really know. Oh, so A is unit in Rust. I'm not sure, programmer. I'm not sure. Can you say what you were saying again? Okay, so we made loops. This is loop and out. Now, is there a way that we could write this even simpler? Even simpler. If I remove these, is it okay? Whoops. Okay, it is. And then if I remove this, is it okay? Because we want to be able to make this so that you can write it without all the extra annotations. And can I put this here and do this? Okay, I can. Nice. Oh, because this type is available to me now. Oh, I see, because it... Oh, right. I can say with type label. Something like this. With type label, right? How can I, module type. Oh, I have to go back to here and I go to with type label equals, this, I think. Something like this. Right, type loop is this. But we could just not do that, and we don't have to show that. We can just go like this. Okay, awesome. Oh my goodness. So this is just like a block, basically, right? So let's change everywhere we said simple to block, right? So it's like we have a particular block here. This way is cool, but I think we can do this without this, because this is kind of like the driver. And this is like how we start. So this is basically like your starting condition. Is there a way that we can write let start label is handle fun go to label like this? Oops, we gotta put this one in here, I think. Right? So can I go instead of this? Are we forcing imperative into OCaml? No. We're forcing terrible ideas into OCaml. Oh my goodness, nice. Okay, so that's pretty fun. That's pretty fun, chat. We're forcing terrible ideas is pretty much the plan. Go to. So what are we doing? We literally say go to out and it just goes to out. OCaml already has classes, but they're, well, and I guess, yeah, you would still call them classes. The objects in OCaml are very sane. Like they're actually pretty nice. No, it doesn't have multiple inheritance. It has like single inheritance, and you can include functions from other ones. I don't remember. I haven't read a lot about it. Like offhand. We'd have to go back and look at it again, but they're like pretty nice. All right, so you guys see this though? We're literally doing loop. Oh shoot, I didn't think of this. We gotta say here. Go to loop n+1. Right, that's the way we want to do this. We don't want to say loop again. We don't want to call ourselves. That's lame. That's lame. Recursive functions? No, that's for comp soy languages. That's for comp soy languages. We only go to. Loop? No. We go to. Why recurse when you can go to? Exactly, that's what I'm saying. What are worse ideas than go to that's not in OCaml? Oh, so we need to find some other ones? There we go. Go to loop. go, and so then this is go to out. So this is kind of fun. The cute thing here, right? Oh, I wonder as well, do I need this anymore? Can I remove this? Oh, baby, nice. I don't have to put this either. So it's like we just pass a go to sort of idea into these functions. It has shadowing, so the last one you inherit is the one they'll be used in the class. Yeah. Need breaks and labels for maximum productivity. Well, that's basically what we're doing, right? The fun thing about this compared to Sozin's idea is Sozin doesn't have any way to pass. We're doing labels with arguments, chat. Type safe labels with arguments. Let's go. Let's go. LGTM, ship it, boys. You can also name the superclass so you can call specific methods. Yeah, the objects are actually not that bad. Type safe labels with arguments. It's kind of like functions if you squint really hard. Create a program in which main function is recursive. That's no problem. Ready to open that RFC for OCaml 6. Oh, we're so back. Oh, man. Okay. RFC, replace let rec with go to. Smart. That's what I'm saying. So then the question would be, is there any trick we can do? We should keep you away from computers for a year. So a simpler option, if we don't allow ourselves to pass state, which really is not very much like a go-to, we actually can do this even simpler. So let's try that really quick. That actually, it also makes things a lot easier. So let's try a version without that. Let's go ahead and copy everything we have here, and let's go with labels only ML. And then let's go to public name, labels only. Oh, right, modules, labels only, and modules main. So let's change this to be, instead of running this, let's run labels only. This way I can still keep this. I don't want to lose everything I've got here. So this actually makes things a bunch simpler, because what we can do here is we can say, hey, there's no, you can't do any shenanigans with constructing things with data, right? So more go-to-ish, right? More go-to-ish, right? And you would just have something like this shared ref, right? So this would be like n, right? Or shared or something like this, right? We can say if shared greater than or equal 10, go to out, shared this, shared is +1. These always just take a go to, which if you don't need, you don't need. And then we'll say this, go to loop, and then we can delete these as well. We don't need n anymore. And then we also don't need to do this, because we'll just have loop. And then here we just return loop, and we just return out like this. And then we have loop 1. We don't do that anymore. Whoops. So this is like, this is actually so much simpler, because we can just we don't have to even do this anymore, because this is just basically units. I actually think we just don't even need this at all. We basically have a get handler. All this returns is something that takes a label to unit. What does this return now? Maybe this isn't even this isn't even what we need, right? Hypothetically as well, you could totally like PPX this, but that's cheating. So goto just takes a label and it returns a unit, right? So this is something that just takes a label and returns a unit like this, right? Get handler. Because when we have the label now, we'll have goto label. And we're just going to get the handler here. And then we're going to call this with handle handler. Handle F and goto. Yeah, all right, because then this whole thing needs to return a unit like this, I'm pretty sure, right? Yep. Nice. Isn't the theme song working? Oh, try again. Implement come from. I was talking about it earlier with well-typed witch, and I'm not sure that that's possible to do. Okay, so now see we have this, and then we say quitting loop. Maybe I just don't have it on. Select, we'll try and delete all of the theme songs from today. I may have just not, yeah. I don't know, you can try again and see if it's going. We probably also should check live streams. Did we get one for today? We did not. Why did we not get one for today? We should have gotten that oh, I think there may be a race condition with when we put those in. Why are we not putting new live streams in? Very suspicious, chat. Very suspicious. I've scuffed something at some point here for connecting and putting in a new live stream. I'm going to blame Shirai, even though it's probably my fault. So that's what I'm kind of thinking. That's kind of what I'm thinking right now. We'll solve that later. Mr. Bibino. I blame Ryan for most things. It's a good strategy. Okay, so this one's even easier. Right? Because now when we're here, right? Oops. When we're here, all we're going to do is we just have loop and out, right? So we can even say function loop and out like this. The DB's made about goto is true. Right? So here we've got our loop and we've got this. So here's our labels. And in fact, you could probably just write this instead as some function, right? You could write this as goto. I don't know if that's better or worse. Do you guys think it's better to do fun goto, right? And you would just write like this pretty much looks like, I mean, this pretty much looks like a that pretty much looks like labels. You know what I'm saying? Like that sure looks like labels. Am I wrong? Is there a way I can write this without having to write fun goto here? Like a nicer way for this? Oh, we could just call, what if we called this instead? Let's say we called this like chunk or something like this, right? And chunk would take a goto here and then do this, right? we get here. So what if we try this? What if we try this? Let's see. Val chunk takes something that does a label to units and a label and returns units like this, right? So we're kind of switching this around. So then what are we going to do with this? Let's try writing handle slightly differently. Let's just shut up about unused variables. So what if instead we say G chunk go to label loop effect unhandled. Oh, right, because we have to go back and we have to handle this. Of course. Right, that was the trick. That's the trick that we need to do. Because this handling just goes here. Now we're in a new block. So we need to go back up to handle and pass go to. So we can make that though, right? Because we can say let chunker is G chunk I think we need to switch the order. Might need to switch the order. Let's try this, right? Because what if we just curry this bad boy here like this, right? So this is here, and we go back down to here, and we say G chunk label in handle chunker, and now we go to here, and we get label go to match label with oh, nice. So now we can just go get handler. We're just gonna delete this. Boom, boom, boom. Oh, oh, baby. The JavaScript responsiveness and typing is unparalleled. Chat, look at this. Look at this. Looks like labels. You know what I'm saying? Does this not look like label? What does go to mean? When I say go to out, I wanted to start executing this. Oh. Oh my goodness. We did it. We did it. Okay, so then the real question here would be, can we do this? Let's switch this back to goto. Let's switch this back to function. And then let's go back to here. And then what we're really going to do is we're going to say, okay, chunk is going to take this goto function and then a label and then unit. So now it's going to say, this doesn't work. This is a lie. What color team? It's my my color theme. Groovebox. Groove Buddy. I mean, I did not make Groovebox. That would be a lie. Fun. Go to label. Oh, handle this. Do I have like a max stack depth or anything, or it's fine? Okay, well, I think if you go this far, then it's okay. You know what I mean? It's a lot of printing. How far is this? 1, 2, 3, 4, 5, 6, 7, 8, 10. We're doing a lot of not. Wait, what is this? Oh, did I just do that? Okay, nice. We are going pretty deep into the stack. We're making a lot of functions and closures. I do wonder if it's possible not to do this, but it's okay. you think OCaml's ready for SaaS? Not as ready as some other options. Okay. So maybe we don't want to go that deep. Right? But like if we go here, it's going to be done in no time. Okay, so that's fine. So it actually works. Chat, I cannot believe how good this works. Oh my goodness. This is literally flawless. You write your block of code. Oh my goodness. It actually works so good, dude. That's so funny. Okay, now we're really back. It's type safe too, chat. It's that you can't do something else. You couldn't say go to out like this. It's gonna give you an error. It's gonna say, dog, that does not work. Modules do not match. We can only go to labels that exist. Right? Because in Sozen's one, not saying like bad, he just said like see if we can implement something different. It's just strings. You could go to one that doesn't exist. You know what I mean? But this one actually works flawlessly. Oh, I can't believe it! I can't believe it! Oh, we can even do make go to like this, right? And we can just say, we could call this like loop. And we could just say like loop start. Does this work? I think it should still work. Oh my goodness, chat. Oh, it gets better every time. It gets better every time. Are you kidding me? Very good job. I think we just made goto in OCaml. That's pretty hilarious. Wait a second. Hodl here, chat. Wait 1 2 in moment here. It actually works with this too, because now when we're writing it like this, we can, oh my goodness, we can just pass data to it too. Oh my goodness. Oh my goodness. This way works even better. Can I go to a location in another module? No. It would only work within itself. But if you had a module that called goto for another spot within itself, that would work. You should be able to do nested gotos still. Go to myfile.rs. Smart. Extra another Frisian considered harmful. Does that mean we can break for loops with goto and if else? You can break everything with this. This breaks all the rules because we never continue the execution of our continuation. We basically just discard this. So this is definitely not what you would want to do. Do I have effect open somewhere still? Is there like a discard? Because the problem, basically, we are like super lying. We are not supposed to do this. Basically, in OCaml, you are supposed to continue the return. Use some of the Dune developer preview. No, I'm using a OPAM switch. Okay, we're back, I guess. I don't know what happened, but it's working now. What up, ZD? Did other people not get theirs playing? What is happening? This isn't the right date, right? Today's the 28th. Insert into Twitch live streams. ID started at, inserted at. I mean, look at this. 1, 2, 3, A, B, C. But why? What? This is just all wrong. This is just all wrong. Why am I not getting a newer Twitch live stream date? I should have gotten one when I... Okay, so... Yeah, okay, so now everybody's... people who just messaged should probably get another one. Ram, say hello. Ram? Hello? Hello? Nice, there we go. Okay, so this part's scuffed. This must need to wait longer or something like this. Such a good one. I actually can't believe that this is, so we could call this like limits, right? We say limits. Dude, that is so funny. I actually can't believe that this is working. It's cracking me up, dude. What happens if we do it again? Okay, so it like, this one is mutable forever, so you do want to be a little bit careful. But that's fine. You would just write something that could generate a new module every time. Or instead of doing this, you would pass like start and stop and then out. Oh my goodness. I actually can't believe how good this works. And it's so simple. It's actually so simple as well. Can you use the limit as a recursive arg basically to use it as a state? Can you use the limit as a recursive arg? No, because all of these have to just take units. So it doesn't really work. We could make it maybe more complicated, but it's a lot simpler if these all just only take... They always just return units, right? So it's basically like, you're just kind of done. It actually is pretty clean. So you can, let's, what's another example of one where you could say like module cleanup? Make goto, struct end, type label is start cleanup, finish, something like this, right? We'd have like start and cleanup and like out of string, something like this, right? I actually don't know how we would get an out value though. Can we make it so that we could maybe have like type ret. Okay, we'll think about this. Let's think about this case. Let's see if we can solve this, because this would be pretty funny as well. So then we'd have like let chunk goto function. Start would be something like, you know, pretend we open up some file handles, right? Like this, right? And then be like oops, one failed. So it's like let we can just go like this. Boo. We can go if success, right? Something like this. Success. If not success, then go to cleanup. Right? Like this. And then you would say go to out success, something like this. You'd have cleanup. No, then you would say doing some work with the handle, something like this, right? And then you would say go to cleanup, like this. So you'd have cleanup, and then it would be something like cleanup. This is like how you do this in like C, right? You know what I'm saying? You would go like this, and then you'd say go to out done. Maybe cleanup should also take a string. And we could say message. And then this would also take message. So then this would say cleanup. Yeah. And this one would be like no. Right? And then we'd have out message. And then we could just have message. So this won't work anymore. This is not going to work. Syntax error. Thumped per. Oh, right. Like this. Okay. So this doesn't work because this no longer returns this. So we can first try this. Done. Okay. So let's we'll won't do anything with loop. We'll just do this one for a second, and we'll go cleanup dot start start with true. Done. Yeah. Boom. Right? So then we're done. But now what would be crazy, right, is if we could do this and we said like let message is this in done with %message. Now it's gonna say message was type string, but we got a unit. So now I'm wondering, how can we make this so that this returns a string? So then this would be, I don't know, result and result. And then this would be Is there a way to say that something never returns OCaml? We'll ask ChatGPT. Are you such beetle things for Kickstart and use this black background for yourself? The black background's good. Can you say that something never returns in OCaml? Because what the problem is, it doesn't know that this doesn't work. Because this is kind of like a lie. This part's kind of a lie because it says that it's not going to return. Because like we never actually finish executing here. So we are like, we're lying here. Because we say that this is just a unit. Is it possible to say that something always raises an exception? I don't think that those work. I think that those are all a lie. I guess this should say here. Labeled A, and this returns A. Okay, so let's say type return. So this says type unit, we expect to type G return. So this should be G return. And then when we get to here, we should probably have go to example G return. And then signature modules do not match. Well, shouldn't I also need to type return is string? Right. Whoops. Let's just take this whole loop one and comment this for a sec and just try this out with, you kind of want something like unreachable. Right, but I don't want to have to write it. That's the main thing. That's actually the main thing that I don't want to do. This method is type rep, but expected to type unit. Okay, so when we go to unit, where are we saying that we could be returning unit? Well, because these other ones always just return. So we can say chunk. What if I put this one first? This type is type red, but it's going to type units. 61. No, because shouldn't these all say that this returns? Okay, so let's just say here for a second, label, and then ret, and this is match label with. Go to cleanup, yeah. How can that one be that it says that it's unit? TJ, I am confused. You know what I probably should have done as well? Is I probably should have like saved everything that we did here earlier. F and go to. I'm confused. I don't know what's going on. Oh, because these. Oh, right here. This one says that we can't do that. Oh my goodness. No way. Okay, so we're so close. We're so close. We're so close. Can we make go to still return unit? Oh, I see. Yep, I see. I see. So why would go to cleanup as the user search type ret? Ah, I see. Yep. Okay, so this. Okay, it would be great if we could say here. Let's go here. Here. So this is where we say go to label. Oh yeah. Whoops. Match label with this. Okay. So now it says this has type unit, but it was expected of type this. Right. Right. Righto there, chap. Okay, so this is where we're getting troubles, because we want to say this. What we want to say is that this returns. We want to say that this returns ret, or nothing. We want to say that this returns nothing, because it doesn't. Kind of real, yeah. We're doing labels, so we're being a bit cheeky about things, right?
Mary Kate and Ashley. Mary Kate and Ashley. Mary Kate and Ashley. Mary Kate and Ashley. I was 8 when I met Mary Kate. That was actually the same day that I met Ashley.
So it's not a yes. So we're taking this video that he did, and we're gonna try and do this differently. So we've gotten a few versions of this so far. I cannot figure out how to do never. Like I can't. I don't know. I can't find a never type. I think it has to reduce to something. How does scoping work here? Good question. Okay, so let's see if we can sort this out, because basically the problem is here. Whoops. So the problem that we have is that this goto here goto has to return a unit. Otherwise, we can't use it like this. You definitely want to be able to do this, I feel like. So if we do this, then it's not so bad, because we can go to here to unit. We can say ret. And now it works, which means we can get out the result from this, because these are all gotos. Can you just wrap the function in another function that discards the return type? Yes, but it's a bit, I would say it's a bit annoying, is it not? I mean, we could say raise, failure. But this sucks. You know what I mean? Like, that sucks. Right. I'm trying to make it so we wouldn't have to do it here at all. So you can do this, right? And you could go ignore like this. And then this works fine, because we're saying like, oh, pretend that we don't care about this value here. Right? Like, this works okay. But I mean, we could do like go to I, you know what I mean? Which is just the ignored version of this. We could pass two different things inside of here. But it's just a little bit still kind of annoying, you know what I mean? Go to 2. So like this way works just fine, right? Because it's like we're saying opening some file handle ... right? Then we're going to get cleanup here. So then we could do start true. No, then we could do the same thing here where we say instead of start true, we'll say start false. And now we're going to get down to here and then we'll say done with no. Right, so see, like both of these, both of them still call cleanup with no, but only one of them says doing some work with the handle, right? We can say maybe we should change this one to like start, and then this one to out. Right, so it's like start, clean up, out. Start. This one doesn't do any work with the handle and then gets to clean up and then out. Right? So it's like, it's literal go to, like in C here. You know what I'm saying? Like we go to clean up here and we come out. We come out here. We skip all of this code in between. Now this is actually pretty easy in this case, because our go-to here is just going to be a unit. So we don't really care. So this one's easy. So when you're not returning anything out of here, can't wait to finish OCaml tutorial, start playing around. Nice, Raiden. Oh, just making go-to in OCaml, you know? Sarah, are effects already in OCaml? Yes, OCaml 5 has them. I'm afraid. Rightfully so. Make it don't go to. That one would be harder. C++ interpreter. Good idea, Dan. Yeah. Maybe just say like cleaning up. What? Change till at. There we go. I'm new to ML families. Nice. So, okay, so this is the only blemish against us right now. May I ask why you are making goto and OCaml? You may. I watched this video yesterday from Sozin, and I thought, that seems fun. Can we do it as well? And now we're here. That's all. What would be really funny is, oh my goodness, we could come back to where we were. Oh my goodness, chat. Okay. Are you describing a procedure call at this point? No, because sometimes we don't. Because we don't have to. So you could totally have this be something like it could take, so when we get the effect here and we say go to here, we could say like let's just do it for the loop one for a second, just for the goofiness of this. No, let's do it for the cleanup one. Let's try this. We'll try try again. Or this one's basically like this one's kind of like await almost. Because then what you would do here is you could say something like go to true. This one's such a bad idea. So then this would be, instead of label, this would take some bool label. And this would be like if C, then continue K with, oh, but we need to have a value. This pattern matches type of A, B, but pattern respects value of this. Do I need to say... Maybe I need to say this. I actually don't know how to write this. Pattern type A, B, but a pattern respecting values of type. Can I not even do this? Oh, I see. That's what I'm trying to do. If C, then continue K, open effect deep. Start. Go to false. Oh, okay. So in this one, we say go to cleanup, right? And then we get to cleanup, and then we go to out. Oh, no, I don't think it's going to work. Because we should be getting... Oh, we haven't tried it yet. Let's try it like this. Okay, so we go here and we go... So we start now. We go to start. We open the handle. Then since it's not here, we go to cleanup. Right? And we go to cleanup and we say cleanup. We go to false. Out. And then we come back to here. We come back to here. And then go to clean up again. Oh my goodness, chat. It literally goes like this. It goes like this. It goes like this. We go into here. We go into here. Then we go into here and we do this. And then we do this. And then we come back and do the rest of this. And then the rest of this. And then here. Oh my goodness. It's like come back later. It's literally come back later. Oh my goodness. Come back later? Yeah, why not? Close for lunch, come back in an hour. Perfection has been achieved. So this is where this is the thing you buy yourself if you're doing this in with effects instead of exceptions, is you can resume. So if you were thinking goto wasn't cursed enough, what about goto and come back? Goto and come back. Oh, it's not quite come from, right? It's not quite come from, but it's like come back. Oh my goodness, man. That's pretty funny, dude. That's pretty funny. Implement come back to your Lua. Come back to this, dude. Oh my goodness. Goto plus come back. Okay, what could we do that would actually be really funny with this idea? What do you think of defer in okay? Could we make a defer? Maybe defer would actually be a good one, though. I don't think there is a defer, though. There's not one, right? So it kind of works. You do go to, then you go back to it once you're done handling everything in the previous one. Right. Make defer, but make spawn a thread and defer that work to the thread. You can. You just have to do it first. So let's try this. Let's go defer, and then we go to await. And let's try defer here, right? So then let's try and do something like this. Okay, we're going to start here. Then it will be we're gonna start something here. What are we gonna start? I'm not sure. Let's delete everything inside of here. Oh, go to, clean up, true, and this, right? Oh no, false. I kind of don't see this one, to be honest. Okay. We could make this a packed module. Ooh, we might be able to do that. We could do a few goofy things with this then. That might be an idea we need to come back to on the other one. But so hear me out here, right? So it's like, okay, what do you normally do when you defer something? Right? Like if you think of something like this, right? You're like, okay, like let x is, you know, file.open xyz, right? And then you want to do something like defer x.close, right? And then you want to do some more things like x read blah blah blah, and then, you know, return the lines. File read lines xyz in here, and then you return lines, right? Like this kind of deal. Right? So can we make this happen? Because this says we should do this at the end. we can do this, right? This is basically like saying, basically then you have hidden x.close here at the end, right? You know what I'm saying, right? Like you have this hidden x.close here. That's what we want to do. Then we want to return the value at the end, right? I'm not crazy, right? I'm not crazy. So it defers in the right order. Well, we'll probably just do one for right now, and then, you know, you could imagine what it would be like if you were doing something different. Like if you were gonna try and do it as a proper feature, right? We don't need to do the whole thing, right? So okay, so what are you gonna do? We're gonna start with something like open. Right? And that will be some string, some file path, right? Okay. So we're going to say something like open, and let's say readme.md. Like this, right? Readme.md. Go to in OCaml. Yep. Okay. So then what do we want to do? All right, we want to say open like this. Why is it saying 39? Can I not say open? I think I can say open. Syntax error. Oh, is it this? Did I scuff something from here? Line 32. Is open not allowed? Oh, because open's a keyword. Read. Okay. Do you have a favorite System 76 laptop? I have a Lemur Pro, which I like all right, but I'm not really much of a laptop person. I love my desktop, though. How would you map tab to accept completions of Control Y without, in just that context, without interfering with any other tab mapped command? That's why I wouldn't. But in fact, we prefer uppercase or even for polymorphic variant. Really? Oh, I like having lowercase ones, I feel like. Something came to mind. Have Neovim folks talk about using WASM for the plugins? It's been talked about, yeah. Okay, so this would be like read path. So what are we going to do? We're going to try and do something like let, and it's hard to do. It's not like impossible, but there's no like, I don't know that there's any sort of thing that we're going to do. Open a file and read the lines in OCaml. Because we want to do this. Because then we want to close this at the end, right? Okay, so this is the one we want to cheat, and we want to do this, basically, right? We want to take this as our idea. And we want to do something like this. So we want to say, let, like, handle is open in path. Here, right? And just shut up about unused for now. Because we're thinking, okay? So what do we want to do now? We want to say go to true. And then we're going to do reading with the handle. And it's, what is it going to say? This is reading of in channel. All right, we still want to do cleanup of in channel. Go to false cleanup handle. Right, we also need to say reading handle. Let's just return. Yeah. Okay. Oh, then we can go to. Oh, we'll just do something like this, right? Maybe we don't need the last one. We'll just say, yeah. Okay. And let's just drop out here, and we'll just try and do this for a sec, right? Something like this. Oh, right. This can't do this. This needs to go to reading. Oh, wait, maybe this doesn't work because we need to do something kind of reverse, right? This needs to be cleanup of string in channel, right? And it would be like message handle message. Oh, right. Then this needs to be cleanup. This doesn't work. I don't think this works. Are you getting a headache from a syntax highlighting? What, like, how so? I'm used to control why the context switch between editors for different projects. Recently been practicing in interviews. Yeah, that makes sense, Kant. So this doesn't actually work because we need to delay this till the end. We need to delay this to the end, basically. I don't code with syntax highlighting, so the colors make my focus move really fast. You don't code with any syntax highlighters. Interesting. Okay, so this isn't really what we want to do. We want to return back to where we were. Oh, okay, so we want to basically have a defer of unit to unit, like this, okay? So what we want to do is we want to go to true, defer, close in handle, like this. Like this, right? So then we have basically like let shared ref of, whoops. Instead of, what did I have here? We want to say like let to deferred is ref of this, right? Please return to the. That's funny. Oh, that's a funny one, Contra. Okay. Want to try scope base? That'd be interesting too. Random, but love your energy. Keeping awesome. Hey, thanks, Cal. Wild idea. Join Prime and Thor for a project. Yeah, I mean, Prime and I talk about stuff that we could work on together. I mean, we are starting a company together and everything with the coffee stuff. But yeah, I'm with you. Okay, so then we would go here. So what would we get here? We'd get defer f, and we'll say deferred is this, and then we'll just continue to nothing, right? We're done. So we don't have anything yet, so we'll just return an empty string. It's kind of like we're not doing anything there. Defer f unit. Go to false, ignore, yeah, message. Where are we not? I'm about to type bool. False, blah, 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 true, blah, 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 go to, blah, 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 blah. Wow, that's quite the error message. Talking about with, so what do we have here? We have defer of some function. We have reading some in channel, which we're not going to do anything with yet. Go to false cleanup handle. So we could do let lines is ref of this, right? And so we could just return lines and lines. Cleanup of string in channel, cleanup of in channel. I think we don't even need this then. We'll just use mutable state. Okay, nice. Okay. We just use mutable state, which is great. Yeah, we're building a coffee shop where you can buy everything in the terminal. Or a coffee, like, brand, I guess. Not really a coffee shop. We're not going to ship you coffee that's already made. You'll have to make it yourself. You know? But, like, other than that, it's like, so that probably is better said as, like, a coffee bean shop. I don't know. What do you call it? An online coffee shop? Ship to Brazil mentioned? Not yet. Current two places we're working on besides US is EU and Brazil. We got to figure those out. Okay, so then we can just go to reading. We don't even need cleanup. Because what we're going to do here is we're going to get rid of cleanup here. And then we will do the defer at the end. Oh, no, we do need a cleanup. We do need a cleanup because that's when we actually have to run the deferred, right? So like, okay, so now we have cleanup and we need to go list iter deferred. And then we're going to return lines. Oh, this is backwards. Yep. Okay. So we can do something like this. We can say closing handle. Oh, we can even make ourselves little let defer at go to f is go to true defer f. So then we can write, oh, and then we can even just say ignore. So then we could write defer go to so you have to type ret string. Okay, that makes sense. It's fine, no problem there. Deferred pauses the value. It says run this function when we're done. The command enter doesn't select for deleting versus control W. Close the tab. Oh, that's tough, Dutchy. Where did you open it? What? Oh, well, your terminal intercepts Control W, right? Yeah, we're working on some other options as well, Slendy. The main problem is, more or less, the main problem is we don't want to do just boring drop shipping with nothing interesting going on. You know what I mean? We want to actually, like, how can I say this in a nice way? We want to actually ship you something good, right? Which makes it a little bit more complicated. Okay, so go to here, true. So then we're going to read from the handle. So this is kind of like our state here. So then this is where we can do this idea, right? Where we can go here and we can go da, 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 da. Is there not just like a read whole file or something? Input file, input. Is there a read the whole file function into a string? You want to make a dropshipper and make 10 cents per item sold? Usually dropshippers I think are making much better than 10 cents per item sold. It's not so. It's more about what we want the brand to be, which is that you really like the the brand basically and the quality. Then this should be go to false cleanup. You don't I should stop watching German streamers now whenever I'm confused. Say, hey. This should be lines. Lines is equal to this. Oh my goodness. I'm pretty sure it worked, chat. That's so funny, dude. So look at this. Starting now, closing handle. Oh, now we're talking. Now we're talking, chat. It actually worked. It actually deferred it, right? We can just show another example here of saying, like this one doesn't matter, right? We can just say sort of like, and another one, right? We can even put this here. And another one, closing handle, done with, and then we read the file. Oh my goodness, so if we wanted to do something anywhere else inside here, right? Like if you were, say, like mapping something and you wanted to like map it over everything. So now the trick would be we should return something that doesn't just have go to, because this part's kind of annoying. We need like go to and we need continue, because this part just looks, this is like come back. This is literally come back. Right? Or like after, or like do. I don't think we can use do though. Isn't do a keyword? We could just call it like ret or something. We could call it side effect. What would you call this? I mean, this is pretty much like call. This is like call this in a sense, right? That's kind of like the goofiness of this part, right? Is this is effectively just calling a function, but it's like calling a label, right? Which is weird. It's like doing this and then coming back to here. And you could execute yourself again in the meantime, which is a little bit weird as well. You could go to something inside of the defer. Oh no. Can you jump anywhere you want? No, you can only jump to these labels, like within this area, basically. So it's like a poor man. It's not actually defer, right? Like it's not actually go to. But it is kind of funny either way, like just exploring what you could do here. I guess the other option would be, instead of doing goto here, you would do, it's hard to learn Linux automation. I don't know what that is, so I don't know. I'm trying to decide. I don't know what that is. Linux Bash. It's not so hard. You can learn Bash, but some parts are easy. So this is like, we could also have like a return. Oh, let's just more.ml. Okay, we'll just try another one. Why did that not yank? What? Yank. Oh my goodness, I just did yank instead of more. Oh, my brain is stuck with go-tos, dude. Okay, so let's try this with more. I want to try something. I want to try a different option here. So what are we going to do instead? We're going to make ourselves a nice little, I don't know what we would call this really, because we want to basically have, I want to try this idea here. We have something here where it's like go to. Well, this doesn't return anything. Units. This one always doesn't do anything, right? But you also need something that's not just go to. We also need something like return. And this one can return some value, right?
These mics and get satisfaction. I hear you saying, man, that's so meta, not.
Type label is G label. Type ret is G ret. Okay, we can just drop these then as well. Makes it a little bit nicer. Up for an hour, still on goto. True. Goto label perform goto. Yep, that one makes sense. And then we'd also want let return label perform return label. You want to really dive in the rabbit hole? Install Arch. Get comfy. Don't install Arch. You don't want this man to have a family? What I really wanted you to do is like halfway through there, just start talking about like anime or something. You could have written that whole thing and had such a good joke. He's in too deep. He wants to learn Bash scripting. Forget the reply. Read the message above. My chakra is collected. Okay, so for effect, I don't know that this will really work, right? Because basically then what we need to pass is we need to pass go to and return. We need to pass both of them. But then that means that this could have a different return value. That's not going to work. It's not going to like that. It's not going to like that sometimes we return a value and sometimes we return nothing. Depending on which one of these are here. That won't work either. So that won't work. It won't like that at all. Okay, so let's go back to this one, because I think this is probably the best one we have. Because this always just goes to some other spot. I like this one, I think, the best. Can we agree that I think this one is the best one of the go-tos? It doesn't let us implement, I guess technically, I think you could probably do this with exceptions. And maybe that would be better. Let's try and see if we can do this with exceptions. Let's go back to more. Because we may not even really need this. Because we're never going to resume them. Type or exception goto. But can exceptions hold value? They should be able to, right? Of G label. But can exceptions would need to have a label that returns a function here. Is that what Sozen does? Or no? Raise goto name. No, it's just a name. Because there's no way to get a value out of this, which is a little bit weird, right? Because like you could return something. You could return something in something that has labels, right? Like you've lost the ability to return anything if you don't do this. So this is really like this to this. Right? And then this is like raise goto label, something like this. But this won't work because that's not a function. Maybe that's not right. So we'll do this. Let's try just this so far, right? So then this is like exception. Or do I write exception? I don't remember. Exception? How do I match? Do I do try match? Because I thought there was a way to pattern match on pattern. We'll just ask it a new one. Pattern match on exceptions in OCaml. Because I thought you could do it without try though. What about without try? Can't you do it in a match directly? No, that's not right, I think. Learn, exception. Exception foo of this, I will fail. Oh no. Protect. Match. Oh, I think I have to do something like go to label like this or something. Oh, there's also nothing here. Aha, right, because it only returns one thing. We don't need to... Oh, okay, so that's it. Okay, nice. We already solved it. We don't need effects at all for this, which is not surprising because we're not going to resume them ever. So this is actually better because I think it'll probably work a lot nicer. Because once we do the exception, we do want to lose everything from the previous stack, right? So that seems pretty good actually. So this way is still very similar to Sozen's, but we really don't need OCaml 5 for this, which is a bit of a shame, you know, because it would have been more fun if we needed effects. To do the kind of thing that we did with defer, we do need effects, because we do need to be able to resume where we were at, right? So if you wanted to be able to resume, okay, well then, in that case, you need it. Now we're just reminding us try catch macro and closure where you just throw objects. Yeah. But there you go. I imagine this would work for nested ones as well. If we just like yoink this and we make another one and we do like small loop, right? and we try and do something like small loop dot start small loop. We start at 0, of course. Oh, but this will only work. This won't work that good because... Oops. That probably helps too. Because afterwards it'll still only do this. So we need to do like a... let make small loop. Can we not do that? That's a little bit, it's a little bit goofy because it's sort of like... Nice. So that does work. So these exceptions, they're different. So it still sort of works naturally that you can interweave them, which is kind of funny, right? Because you're doing different go-tos inside of them. So that actually works pretty good. We could instead of small loop, let's call this small loop. Let's call it inner loop. Okay. Can we go to random place in your code? No. No, I don't think we can do that. After all this filthy elixir, it does, Benji. Thank you. Thanks for saying so as well. Elixir made me feel so dirty, I had to try and add goto and OCaml. We can say loop. Actually, let's do... Then we'll go to using exceptions and templates in C++. Now this language is usable. Finally! Finally, go-tos. I mean, this is the way that you would, like, think about using a go-to anyways. Is like, oh, go to the cleanup. Otherwise, here we go. Now we're going to go to cleanup. If only there was a way... If we had fall through, that would be hype. Or we could say, like, continue to the next thing. That's the only thing we don't have right now. Oh, that's interesting. Does he have that? Oh, interesting. So his, I think, if you don't go to loop, go to loop, go to loop. If you didn't do this, it'll go to the next one. That's a shame. We don't have that in ours right now, right? It doesn't really like fall through to the, or not really fall through, but like I want it to be like these are labels, right? And you would just keep on executing till you're done. We can't do that for sure. That definitely won't work. I swear the console looks like my servo automation setup, lol, just a bunch of commands being executed. Well, yeah, that is what we're doing. So now that makes me think, okay, if we do that, then we can't pass data here, right? You know what I'm saying? We'd lose data because there's no, you don't know what the loop would be, right? So if we go back to our first one where we had this main here, and we could change all these to this as well. Oh, this one has this labels only. Shoot, did I destroy labels only? I did. Dang. Okay. Well, whatever. I have led troops and informed employees that we are step currently in, so loops get printed a lot. Because what would be cool, right, is in like this case here for cleanup, it should just automatically go to cleanup. Right? You know what I mean? It should just go to cleanup. I mean, we could do like continue. Right, like this, you know what I mean? Where we say like we want to continue down our states. We'd have to do some derive. We'd have to cheat a little bit and add PPXs for that. Let me go pee. I'll be right back. Wow. Hey. Fancy meeting you here at the end of the video. Just go ahead, give it a smash. You know. Wow, the like button. You can make fun of me in the comments for that one. I don't even care because you made it to the end of this video. Thanks everybody. See ya.